Okay.
Welcome everyone.
Sir, good
I think
afternoon.
we should begin.
Okay, good afternoon, sir. Shall we start? Shall I shake this hand?
Yes,
Kuldeep,
please
sir?
start. Floor is all
Yeah.
yours.
Okay, sir. Okay, sir. Okay. So, good afternoon, everyone. Attending this webinar, I, on behalf of Ministry of Housing and Urban Affairs,
Good afternoon. Good afternoon.
may I request everyone to switch off their mics so that you can listen to me, and after that you can listen to the RJS. So, good afternoon, everyone. Attending this webinar, I, on behalf of Ministry of Housing and Urban Affairs, Government of India, and Building Materials and Technology Promotion Council, GIZ, and on my personal behalf, extend a very warm welcome to all the participants to this second webinar on Lighthouse projects being held today. I also extend my warm greetings to Shri Kuldeep Narayanji, Mission Director and Joint Secretary, Housing for All, Ministry of Housing and Urban Affairs, Government of India, for his gracious presence in this webinar, along with other officials from Ministry, PMU team, and GIZ team. I also welcome state level nodal agency, MP, their officers, SLTC and CLTC team, including officers, engineers, architects of Indore Municipal Corporation. The representatives of technology provider, including the construction agency personnel, are also welcome to this webinar. Today's webinar is being held at Indore, which is one of the LHP site under Global Housing Technology Challenge India. And through this webinar, our efforts will be to make participants understand and learn the innovative construction system being used in this project. The participants not only include TECHNOGRAHIS, who registered through online enrollment drive initiated by HFA Directorate, but also we have engineers, architects, planners, professionals, faculty members, developers, technology providers, and students from architectural and engineering colleges of MP as well as other parts of the country. The overall objective of this webinar is to educate the attendees about the new construction systems being used in the project and build capacities within India. We also make all of you aware about the initiatives being taken by Government of India to introduce these innovative emerging construction technologies in the construction sector. Let me also tell you that these construction systems are resource efficient, climate responsive, disaster resilient, and energy efficient. Also, these technologies impart speed to the construction activities and help deliver superior affordable housing and infrastructure, which is not only better in terms of structural and functional performance, but also in terms of quality, durability than the conventional cast in situ, RCC framed and brick construction. At present, to showcase these innovative construction systems, 6 lighthouse projects are being constructed in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Ranchi, and Agartala. At all these 6 lighthouse projects, 6 distinct innovative technologies are being used, and we'll be holding these webinars at all the 6 places for participants to understand all these systems. There will be around 40 webinars till November 2022. During the webinar, we will also be taking you to the virtual tour of Lighthouse project site, which is Indore today, to take stock of present construction activities and give you hands-on experience on the construction technology and processes being used in the project. Let me also share with you, it is a unique opportunity where theory is blended with field exposure. I sincerely hope you will be benefited by this webinar and learn new things which can be implemented by all of you in your future projects. Before we get into the technical details, it's my pleasant duty to invite our JS, who has been leading the mission from the front and a constant source of inspiration to make his opening remarks. Over to you, Kuldeep, sir.
Thank you, Saleshji. Am I audible?
Go ahead. Yes, sir.
Okay, great. So, since the webinar is about the live laboratories lighthouse projects, today concentrating on one of such sites like Indore, I will not take much time except emphasizing 2-3 basic points. See, these lighthouse projects, all the 6 of them, have been conceptualized to popularize such new construction technologies, which are not only resource efficient, fast paced, but also which have more of a climate resilient, otherwise resource efficient. So this is my first request to everyone attending, that if you are not registered as Technograhi, please come forward and register yourself as Technograhi. Number two, in these kind of webinars, what you are seeing, we are in these kind of webinars, what you are seeing, we are also showing the kind of activity as at the project site. So you may like to understand how it is being done. You may like to visit the place also whenever you get the opportunity, and you should promote this technology in all areas wherever you are working, because there are few things which are best promoted through words of mouth. You see something, you like it, and you see its utility. See, if you are constructing a building and through traditional technology, usual one, let's say it takes 2 years, and similar building being constructed through some good new technology like the ones we are seeing in this case Indore, if it takes, let's say, 1 year, 15 months, any time saved is money saved. Here is the time value of money. Always completion of the project in less time always means that your project execution is good and you are saving money on the project. So these technologies need to be promoted.
Is it visible to everybody?
Yes. Yes.
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse project using prefabricated sandwich panel system with 1024 dwelling units
Hello,
in
sir.
S+8 configurations, along with all basic and social infrastructure facilities is being constructed at Indore in partnership with State Government of Madhya Pradesh. Honorable Prime Minister laid the foundation stone of 6 lighthouse projects, including at Indore on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। इंदौर में जो घर बन रहे हैं वो उनमें ईंट और गारे की दीवारें नहीं होगी, बल्कि प्री फैब्रिकेटेड सैंडविच पैनल सिस्टम इसमें इस्तेमाल होगा।
Lighthouse project Indore is progressing well, and this video highlights the status of the project. In this system, the EPS cement panels are manufactured at the factory in controlled conditions. Sandwich made out of calcium silicate and cement with EPS panels walls act as wall panels. These wall panels replace conventional brick masonry and can be used as load-bearing as well as non-load-bearing walls. Panel and groove are joined together for making the wall. These panels can be used both in RCC and steel frame structure. In Indore, steel frame structure is being used. Construction of Lighthouse project Indore was started with excavation of site, followed by laying of plain cement concrete. Construction of Plinth Beam and backfilling to complete the substructure. While foundation works were going on for all towers, The prefabricated steel components as well as sandwich panels were made ready in factory. Superstructure work started in all 8 towers sequentially, involving assembly of column, beams, placement of deck sheets, reinforcement, including fixing of electrical and plumbing services. Concreting of 40 out of 72 slabs have been completed. As the installation of steel structure progressed in different towers, EPS sandwich panels are also being fixed from lower to upper floor. Superstructure framework reached up to 6 floors in 4 towers and 4 floors in other 4 towers. Simultaneously, infrastructure work of drainage, sewerage, underground water tank, erection of compound walls, community center, solid waste management plant, electrical substation, etc. are also going on in full swing. A sample flat with all amenities is ready in Tower 3 for showcasing it to the beneficiaries and other stakeholders. The LHP Indore is serving as live laboratory for learning and dissemination of knowledge. About 350 technograhis and other stakeholders have visited the site to learn the use of innovative technology in real project at site.
Thank you, Manish. Before I start making the presentation on Global Housing Technology Challenge and the technology, Kuldeep sir is there. Sir, would you like to add something because connection was lost while you were talking? So would you like to say a few words again?
Thank you, Shailesh. I think last 2 lines, what I was that was a repetition only. But at the cost of repetition, let me again emphasize what I am expecting from the session. That from this session, I'm expecting that all participants will learn this who have not seen on site how this technology is working through technical presentation and video of the site. I'm expecting this session to be an interactive one where we not only learn about the technology, we also promote others to come and see and promote this technology in other projects, public projects, private projects, where it can be utilized. Let me tell you, this is a very good step like our own CPWD is doing, that they are preparing tenders which are technology agnostic. That means such tender and VOQ will be published where it is not mandatory for person to use any particular technology. They are free to use their own technology. So these technologies for which SOR is approved in CPWD schedule of rate, they may also be used. So this ecosystem which need to be promoted through our activities, and in this respect, this kind of webinar is a welcome step. Thank you, everyone.
Thank you, sir. Thank you very much for your guidance and kind words. And
let me also add. Let me add students who are there attending the webinar. You may think about doing your project work, thesis about these technologies. These are of the things of the future which you are seeing in present. So I welcome you all and best of luck. Please start the technical presentation.
Thank you, sir. Thank you, sir. Now we will start the technical session. Before I start the technical session, may I request everyone to mute their mic, because still there are a lot of interference we are getting, so that you can listen to me explicitly. Also, as sir was telling you, this is just a beginning, and whatever you learn today, try to adopt them, try to replicate them in the field. We will also be taking you to the virtual tour of LHP site at Indore. You must have got the idea, the kind of technology being used at Indore. But before I get into the specifics of project at Indore, let me very quickly give you the initiatives taken by Government of India through Global Housing Technology Challenge, which was conducted in 2019, and through which we created a basket of innovative emerging construction systems, and which we are promoting and which we would like to make as future technologies for the construction. So first, I will give you the overall overview of the 54 construction systems which we have shortlisted and right now promoting across India. And then after that, we will get into the specifics of LHP Indore project. Also, please do not hesitate. Write your questions in the chat box, and at the end of the session, we'll be taking all those questions one by one. So you can write your questions in the chat box, whatever comes to your mind, and to the best of my capabilities, I will try to answer that question. Okay, and you can also share your experience if you have any through the chat box. So let me share my screen with you. I hope everybody is able to see. Manish, Manish दिख रहा है क्या? Okay, okay, okay. So this is just a presentation comprising of around 25 slides, which will take you through the construction systems which we have shortlisted. Before that, let me just very quickly tell you because the entire effort which we are doing today is under the ambit of Pradhan Mantri Awas Yojana Urban, and through Pradhan Mantri Awas Yojana Urban, the housing for all is being ramped, and so far we have sanctioned around 1.15 crore houses. It has gone up to 1.2 because yesterday we had a meeting, and this is just a progress. Okay, and it is not only that through Pradhan Mantri Awas Yojana we are constructing houses, but it generates a lot of employment. More than 2 crore jobs have been created, and at the same time there is huge consumption of cement and steel as well. Under this Pradhan Mantri Awas Yojana, we are also running a technology submission through which we are facilitating use of clean, alternate, innovative construction systems, building materials, processes, and technologies across India, so as to have sustainable development, disaster resilience, quality, affordability, and so many other things which we do normally lack when we construct houses. So under technology submission, we conducted a global housing technology challenge in 2019 on March, and it was inaugurated by Honorable Prime Minister. And this is the website of GHTC India. You must make a note of it and go through this website, because this website contains all the information about innovative technologies, audiovisual capsules, and presentations, and all those things. So that kind of information on these new technologies, alternate systems, you will not get anywhere else at one place. So through this Global Housing Technology Challenge, we shortlisted. There was a committee, technical evaluation committee. All the global players were invited to our country, and it was a huge success. And then they all were asked to showcase their construction systems technology in an exhibition, which was conducted in Vigyan Bhavan, and through that challenge, we could shortlist 54 new technologies. And these 54 new technologies are divided into, for the sake of clarity, we have divided them into 6 categories. And these categories are written here. I will just explain you one by one pictorially all these categories. And right now, what we are doing under each category, we are constructing one LHP to showcase that category with the distinct technology. Okay. So, all these lighthouse projects were, inaugurated, or the foundation stone was laid by Honorable Prime Minister on 1st January 2021. And because of COVID, we could have completed all those projects, but because of COVID, and these projects are still going on, but very soon we will be completing these projects. And, while laying the foundation stone of these 6 lighthouse projects, Honorable Prime Minister desired that these projects should be treated as live laboratories. And this is just a beginning, and we should try to replicate these technologies across India. We should try to learn through these lighthouse projects, and that is why this attempt is being made by Ministry of Housing and Urban Affairs to disseminate the knowledge, to make people aware, to spread the knowledge, and with the idea that these construction systems are adopted for the future constructions. You might be wondering that all the time I'm talking about construction systems. What does it mean? So, no, actually, what we have. all over the world, normally the construction takes place in by these two, methods. One is load-bearing construction, where you, or a masonry construction, where you create the walls brick by brick by laying bricks one over other with mortar, and then you have a cast in situ slab. Otherwise, the most omnipresent system across word is this RCC frame construction, which you see on the bottom right, where we have cast in situ RCC construction, which comprises of reinforcement cage, and then the concreting is done, and then slab is put, and then are filled with bricks. And both these systems, I don't want to get into details, but they create a lot of, they are unsustainable, they are not resource efficient, because similarly, a lot of sand aggregate is being used. They create dust, noise, and air pollution. Sometimes when we talk about quality is also being questioned. And one of the biggest thing is they are slow track construction. And that is why you find that most of the projects being done with these conventional construction systems are caught with cost and time overrun. And cost and time overrun means that a project, when you start with the X cost, by the time it is finished, the cost gets doubled. And same thing happens with the time. The project which was supposed to be completed in 18 months, it takes 24 months or 36 months, or even may go beyond that. So all these technologies which we are discussing here, or which we shortlisted, they fare better than the conventional construction system in all regards. And these are the qualities. You can deliver housing infrastructure at a much faster speed through these technologies. Quality, safety is also very important, because India is a country where we have several natural hazards, whether it is earthquakes, cyclone, floods, or landslides. So disaster resilient or multi-hazard resistant construction is the need of the hour, and all these technologies ensure disaster resistant construction. Sustainability, with India being signatory to climate change mitigation strategies, and we need to reduce our carbon footprint, sustainable development is also a call of the day. And most of these technologies which we are promoting, or which we shortlisted, are sustainable technologies. And when there is a question about thermal function performance in terms of thermal sound and fire, so all these technologies fare better. And just to give you any statistics, by employing these new construction systems, you can considerably reduce the energy use. You can considerably reduce water 40%, greenhouse gas emissions, this carbon dioxide. Please mute your mic. I'm hearing some voices. 35 up to 35% the greenhouse gas emission can be reduced. Okay, and also the waste minimization is also one of the important aspect when we do any construction work. So by employing these industrialized building systems, you can reduce up to 75% waste. And now let me, as I told you, that these are the 6 technologies, and I will pictorially, I will explain you all these 6 technologies. So first is 3D volumetric construction, and you can see here, instead of using cast in situ RCC frame construction, where you do beam, column, slab, you make the entire house. I'll just take the pen. You make the entire module in the factory or in the casting yard nearby, and then just put one over other to create the entire block. And you can now you can understand the merits or advantages. Instead of doing in pieces, you are doing these modules, and that to controlled condition in a factory, and then putting them one over the other like Lego blocks. These are some features of them. You can see this is a picture from Indian construction site only. So this is how it is being done, and this is how it is being put one over the other. So through Global Housing Technology Challenge, we could shortlist 4 companies who are into 3D volumetric construction. And we are currently doing a project in Ranchi using this particular system, and this first time users in India of this 3D volumetric construction. And in days to come, we will be holding a webinar there itself, and you all can go through that virtual tour which we'll be conducting at that site. And you can see these are the pictures from the site. At the casting yard, you can make these modules, and then you can put them to create a multi-story stock. Second category is 2D precast concrete construction, and here in the first one which I showed you, we are making the entire module or the entire room. Here we make these structural components. Again, these structural components are made under controlled condition, either in the factory or in a casting yard in the vicinity of your project. And if to make you understand, you all must have seen the how metro is being constructed. So the big girders and all, they are being cast somewhere else, and then they are brought to the site, and then they are assembled at the site. So same kind of thing is being done for creating a housing stock or multi-story towers. So you can see this is a wall element. Similarly, you can have any element which you desire, and then transport them to the site and assemble them to create a building structure. And you can see these are the components, whether it is a staircase, slab, and what you see this follow is a the slab or a roof. This is a wall panel. This is a staircase panel. So all these things are made in the factory and then brought to the site. We could shortlist 8 companies who are into precast concrete construction, and this is the list. And you can get all this information, including this presentation, on GHTC website. Okay, and the project which we are doing using this category is at the Chennai. The project is more than 90% completed, and this is the picture from the project site. So the project started on 1st January 2021, and right now when I'm talking to you, the project is almost complete, and it is using these technologies. And near to the site, they have a casting yard where they are making all these beam columns and walls, and then assembling them here like this. Third category was pre-engineered steel and light gauge steel structural system. And here nowadays steel, use of steel in building construction is gaining importance, and it has become very popular, and it needs to be promoted. So instead of this, you can have these steel beam columns which are manufactured in the steel factory, and all you have to do is you have to bring them to the site and either weld them or do the through nut and bolt you can erect the entire skeleton of your building. And there is another category in this, which is a light gauge steel structural system, where it is a galvanized lightweight light gauge steel, and this is also gaining a lot of importance. In fact, during COVID times, number of hospitals and isolation wards were constructed using these technologies, and all these technologies require minimum water. Okay, so through the Global Housing Technology Challenge, 16 companies were shortlisted, and the list is given here. And what we are doing in Agartala, we are using this technology. You can see here. So here, this is a steel, the skeleton, so steel beam and column. And what you have wall is of light gauge steel structural system. So this is a light gauge steel panel, and this is a hot rolled steel beam and column. And all these things are made in the factory and then brought to the site. So this is the picture from Agartala LHP site. We'll be conducting a webinar there also. Next, let's move to the next category, the fourth one. It is drywall construction. Drywall construction means you don't use brick. You get the wall, the entire wall made in the factory, and all you have to do is you have to just put them in the empty spaces to create your entire room. So there are several kinds of wall, sandwich panel. They are called the elements available in the market right now, and you can see from this picture. So just imagine instead of putting brick by brick to create a wall, you get the entire wall made in the factory, and with openings, without openings, with services, as per your requirement, that can be done in the factory. And what you have to do is just over the already laid foundation, you can just erect that walling element. So this is the EPS panel, just to show you a picture. And there were 9 companies which were shortlisted through Global Housing Technology Challenge. You can see here, and we are using this. Yeah. So we are using this dry wall, this sandwich panel system. I will show you another picture and will give you a detailed lecture on this. So this is the technology which we are using in Lighthouse project Indore, and I will be taking another lecture after this lecture to give you in detail about this technology. So what you can see here, this is the steel structure, and the wall is of that panel. And the panel being used here, I think we have a technology provider also. So this panel is called Rising EPS cement panel. This panel is also being used for the first time in our country, and in next session I'll explain you this in detail. Let's move to the fifth category, which is monolithic concrete construction. Here, this is a customized formwork system made of aluminum or steel, and for the entire module, the formwork is made in the factory, and then over the already created reinforcement cage, you put this formwork and then do the concreting in single pour, so that you get a monolithic structure without beam and columns. And this technology has gained quite a popularity in India, and maximum number of houses being constructed with this technology. There were 9 companies which were shortlisted through Global Housing Technology Challenge, and we are doing a project in Rajkot. The first webinar which we had was in Rajkot, where this technology was explained in detail. And in Rajkot, we are using this. This is called tunnel form technology. Tunnel form. It is another variant of monolithic concrete construction. The slide I showed you before. So here, instead of making all the 4 walls, you make 2 walls and create a tunnel, and then the outside walls are filled with the infill, which can be of brick or AC or any kind of block. The last category is stay in place formwork system. This is also very interesting. So all of you understand what is formwork. So formwork is normally, after the construction, formwork is removed and then sent back. In this technology, the formwork is left in the structure to act as the part of the structure. So that is why it is called sacrificial or stay in place formwork system. So this you can see here. So this first acts as a formwork, and once you do the concreting, then it acts as a reinforcement or as insulation. Here, in this particular case, it is acting as insulation. And you can see there were 8 companies which were shortlisted through Global Housing Technology Challenge. And right now we are doing a project in Lucknow where we are using this stay-in-place formwork system, and it is called PVC wall form. I think I have a picture. Yes. So this is a kind of PVC wall form. It is a stay-in-place formwork system. So these walls are manufactured in the factory and then brought to the site. And this is a pre-finished wall. So with the color, the kind of color you want, that color, in that color, the wall will be supplied to you at the site, and all you have to do is erect that wall. So that is all just to give you the context of the global housing technology. Through these 6 categories which I just explained you, each category is being showcased in one LHP. So today we are going to discuss that precast sandwich panel system which we are using in the Lighthouse project in Indore. And you can see it's also we have been promoting adoption of these new technologies across the country. Also, we have been working hand in hand with the CPWD and other line ministries, including Ministry of Commerce, where the Bureau of Indian Standard is there. So we are trying to, create an ecosystem by creating detailed specification, schedule of rates, and standards on these technologies so that they can be mainstream. Also, through Pradhan Mantri Awas Yojana, 1.6 million houses at present are being constructed with these technologies. So this was in journal the efforts of Government of India regarding shortlisting of these technologies, 54 new technologies, which you might be hearing again and again. Now, I will switch over to my next lecture, which is specific on Indore project.
Sir, your voice is muted, I think. Can you unmute your mic?
Yeah. You are able to see the screen? Hello?
Yes, it's visible.
Visible? I am audible also? Okay.
Yes.
So let's go to the specifics of Lighthouse project at Indore, and I will explain you in detail the technology being used here in Indore. And my contents of my presentation is as follows. And this already I explained you that there are 6 categories, and each category is being showcased in one of the LFP projects. So here what you see in red is precast sandwich panel system, which is the technology which is being showcased in the Indore project. Okay, and these are the 6 projects. Today we are going to discuss this Indore project, which comprises of 1024 houses in S+8. S means stilt plus 8 configuration. Okay, and the other places, all of you know, we have already conducted one webinar on Rajkot, and then we'll be moving to other places as well. And as I gave you earlier, as I told you earlier, explained you earlier, that these are those distinct categories being showcased in these LFP projects. So before we move into the technology and other details, let me just give you the general architectural feature of the project. The total plot area is around 40,000 square meter, and you know, just to keep the green, 15% is the ground coverage, and 10% area is kept green. And this is a long plot being given to us. So there are 8 blocks, and each block is 9-story, and the entire thing comprises of 1024 houses. And at each floor, we have around 16 dwelling unit, which are like this. So each you know, dwelling unit comprises of 2 rooms with the bath, toilet, separate access from both, and along with a balcony. Also, you know, whenever we do this kind of project, this is the plan of a dwelling unit, and we need to adhere to the National Building Code norms. National Building Code gives the norms regarding you know, dimensions, width, height, balcony width. All those space norms are being given by National Building Code when we talk about EWS and LIG housing. So all we need to strictly adhere to the space norms being given by National Building Code. So all these plans which we show you, the dwelling unit plans, they conform to National Building Code norms. So the carpet area, just to give you, it is 29.04 square meter. Built up area will be slightly more. And in addition to this, we have also incorporated other features, like all the lighthouse projects which we are doing must have green rating as per GRIHA. It is you know, mandatory to obtain at least 3-star rating in all the projects which we are doing. Renewable resources also being stressed. So renewable resources in terms of rainwater harvesting and solar lighting, solid waste management. All these projects must have their own STP and the wastewater management system. And when I say wastewater management system, that means recycling of wastewater and you know, putting it back into the system so as to use that water for flushing and you know, gardening purposes. Also, being high-rise structures, the fire fighting norms need to be complied with as per National Building Code. Now, the technology which we are using here is, as I told you, that precast sandwich panel system. But since it is a high-rise structure, and this, when we are using a precast sandwich panel system, you need to use it with some skeleton structural, with some structural system. So that is structural system here being used is steel structural system. In place of this steel structural system, you can use cast in situ RCC frame construction as well. But since we wanted to showcase the new technology, so what we have done is we are using this precast sandwich panel system with this steel structural system. Okay, and this already I explained you what we are trying to do. We are trying to replace these kind of load bearing and RCC frame construction by these kind of innovative construction system. And whatever I explained you today, now it is obvious to you. Look at the speed, look at the waste, look at the other structural and functional performing parameters. You will find all these technologies have an edge over that. So this sandwich panel system, which is see in this picture, if you see here, you are using the bricks or AAC blocks to infill this wall. Here, this panel, which is made in the factory, is used to create this wall. And this is a sandwich panel system comprising of a core, lightweight core, which is of PS, very light in weight, and we have 2 calcium silicate boards. So this provides better thermal the performance. And these beam and columns are again manufactured in the factory, and this system we are calling as a hybrid system. So this is a hybrid system comprising of prefabricated sandwich panel as for walling and pre-engineered steel structural system for skeleton of the building. And these the sandwich panel system, as I told you, are made in the factory. Now let me explain you one by one these structural elements. So if you look at this right hand side schematic diagram, this explains you the components, structural components. So what you see here, any building can be divided into two parts. One is substructure, which is below the ground, and another one is superstructure, which is above the ground. So below the ground we have foundation. So this is that foundation we are talking about. And then above the foundation you have that structural superstructure, which comprises of a structural system. And so structural system is nothing but that beam column system or a skeleton. Suppose you compare it with human body. So what we have is we have a skeleton. So that skeleton comprises of that beam and column. So here we are using this skeleton, steel structure as a skeleton. And for walling, we are using this sandwich panel system. Okay. Then this is your roofing system. Here we are using a diaphragm, which also I will be explaining you. And this is that walling system. So any building can be divided in terms of structural elements into these four. One is foundation, another one is structural system, which is a skeleton of your building, then your flooring and roofing, and the last one is the wall panel systems. Okay, so in this project, foundation, in fact, in all the lighthouse projects which we are doing, we are going for the conventional foundation. When we talk, say, conventional foundation, because soil strata, soil conditions vary from place to place, so one solution will not work everywhere. So based on the detailed soil investigation, geotechnical investigation, bearing capacity, water table, soil strata, foundation is normally designed. And again, depending upon this soil condition, whether it is a alluvial soil or rocky terrain, you need to have isolated footing or rough footing. So that is designed. And once you come at the ground level, after that, the real implementation of that technology start. Yeah. Okay. So here in this, okay. So here we are using combined and isolated RCC footing.
Sir, I think there is some other screen which is showing. Can you just reshare your screen? Your Gmail has come on the screen.
Who is Shailesh Kumar? Just shared his screen. Who is this Shailesh Kumar?
Someone has shared its Gmail screen.
Sir,
Shailesh Kumar, Mr.
yes,
Shailesh
sir. PMUV outlet, sir.
Mr. Anka.
I remark Rasko.
Yeah, it's visible now, sir.
Yeah, okay. See, please, I again humbly request all of you to please don't share your screen. Do unmute yourself so that you can listen to me. So here, what I was trying to tell you, that based on the, it is very important for all these projects or any civil engineering project or any infrastructure project to first carry out the detailed soil investigation, and based on that soil investigation, you need to have your the foundation design. And so in this case, foundation is RCC combined and isolated RCC footings, and wherever we have staircase or lift well, there we provide shear walls. Okay, I will explain you that why we require shear walls and staircases and lift wells when I show you that staircase portion. Also, you might be wondering that why we are using steel. So when you have to connect steel with with the concrete, so you need to create a base plate, and you might have seen, and through nut and bolts, these steel columns which are manufactured in the factory, they come with a base plate, and that base plate is put on the already grouted bolts to erect these columns, and on those columns, these horizontal members which are called beam, they are connected through nut and bolt. In fact, I will show you that also in pictures. Okay, and then once you come to the floor level, all the footings and those columns which are coming up to plinth level, they are connected through a plinth beam. So what you see here is a plinth beam. And again, it is a good practice to connect all the columns at the ground level through a plinth beam, so that in the event of an earthquake, the building goes in unison, or it has that box-like action. Okay. So so this was about foundation. So we have conventional foundation, and foundation is combined footing and isolated RCC footing. And so this is the kind of footing. In fact, I will show you another picture. Okay, then I was talking about a structural system, and structural system means the skeleton, skeleton of your building. So skeleton of this particular building comprises of this horizontal members are called steel beams. These are called beams. So these are of steel, which are manufactured in the factory, and these are the columns, which are vertical members. They are also manufactured in the factory. So as per your requirement, as per the sizes and shape, the order is given to the factory, and they will specifically manufacture these steel beam columns, and then they are brought to the site and just erected through nut and bolts like this. And then these empty spaces, these are called infill spaces. So these infill spaces are filled with infill walls, and here for infilling these walls, we are using an innovative construction system, which is a precast sandwich panel system. Okay, now next is roof. So here again, we are using a deck slab. So you all might have seen how the roof is being constructed conventionally. What normally we do, we put a formwork, and then over that we put the reinforcement cage, and then we do the concreting of 4-inch, 4.5-inch, depending upon the span of your room, 4 and 4. So that is called cast in situ slab or roof, whatever you call it. Okay, and here we are using a deck slab. So what we do here, over already put girders, we put a deck sheet. So this is a deck sheet, profile sheet. It is galvanized steel. So this is a deck sheet. Over that reinforcement is put, nominal reinforcement is put, and then up to 3-inch screed, concrete screed is laid over this. Okay, so this is called, again, this is a another kind of slab other than your conventional cast into slab. So this is a deck slab which is being used here, and it requires less reinforcement, less concrete, and also this profile sheet which I'm talking about acts as a formwork, and then it acts as a part of the slab. Then this is the major innovative construction system which we are using here, and this is prefabricated sandwich panel system. Just to show you, this is the cross section of that sandwich panel system, and what you see. So why it is called sandwich panel system? Because this. Yeah, I will just take a laser pointer just to explain you. You can see. So this is a core. And this core is sandwich. Primarily, this core is of light. It is lighter and softer. So this is a light core which is sandwiched between two outer faces. So these faces are calcium silicate boards, or it can be MgO board, or it can be fiber cement board, or it can be aerated concrete AAC panel. And then in between you put lightweight concrete, or you can have a conventional concrete. Here they are using a special concrete which is called elevated concrete. And what you see, this white dots here, they are the dots of EPS granule walls. Okay, so here aggregate is being replaced. Normally in a concrete comprises of cement, sand, and aggregate. And I would say cement plus fine and coarse aggregate. So fine aggregate is sand, and coarse aggregate is that gitti, which we call. So here that aggregate is being replaced by this EPS granule wall, making it very light. If you compare the density of concrete is 24-25 kg per meter cube, and here the density is less than 1000 kg per meter cube of this particularly coarse. So that is why it is called sandwich panel. And this is just to showcase you the cross section. Otherwise, these panels come of specific width and specific length, depending upon your project requirement. Also, let me tell you here, all these technologies are customized, suiting to your requirement. So as per the spaces in your structure, these precast prefabricated sandwich panels are being manufactured in the factory and then supplied to you. So like this, they are being supplied, and all of them have tongue and groove kind of system. So you can create this kind of wall within no time. Okay, and again, this is a picture from this project itself. So you have that skeleton, which I just explained you. Then you have a deck sheet for slab, and then you do the walls with this innovative construction system, which we have showed you here. And in fact, I have written it's being written here. The core material is in solid state posed under pressure. I will show you a picture again of the factory setup, and panels are moved and transported to the site. So this is a typical setup of the factory setup, where where that they have this kind of setup. It's all controlled through a control command center. All these materials, the raw materials which are used to create those panels are in exact measured quantities. Through a computer, they are fed into a mixture, and through that mixture, they are poured into the molds, and then they are vibrated, and then these panels are put for curing. Once they are cured, they can be packaged and shipped to the sites. This is picture again. This is being a factory setup of this prefabricated sandwich panel system in India, and this is a picture from there. So you can see here. This is that mold I was talking about, and these are those panels, and that's how they are being put here. Just to give you the dimensions, as you can see here, this is the panel. So this is that calcium silicate board which I was talking about, and in between you have this elevated concrete, which is a lightweight concrete. And what you see here is this is a tongue and groove or slide and lock kind of arrangement. So when you connect one portion of wall with another portion, so this is a slide and lock arrangement, or a male, female, or tongue and groove. So this groove goes here to create a connection. And what you do here, you put a layer of rich mortar here, and then you connect these two so as to have a customized. The length can be depending upon the story height of your building or clear height. What you get below your the soffit of your beam and of a slab. So of that length, these wall panels can be manufactured. And then the width again, as per your requirement, the width can be around 2 feet, and thickness depending upon your application. If you want to use it for load bearing or non-load bearing, the thickness varies from 50 to 250 mm. The idea here is that as per your requirement, you can have the thickness varied, you can have the length and width varied. In our project, particularly in the project of Indore, the height of the panel is 3 meters and the width is it is I think wrongly written is 2.4. So height of the panel is 2.4, and and the width is 2 feet. Okay, and the thickness of panel for external walls, the thickness is 120 mm, and internal wall, because internal you don't require that much of thickness, otherwise that will be wastage of space. So you have a 90 mm internal walls. And when you're constructing a room, so it's not that you have those simple wall sections. You have L, T, corner joints, and 2 wall joining together, C joint, T joint. So for all those L and T joints, especially special wall panels are being manufactured in the factory and then being supplied. Okay. So this is just to give you how light these panels are. You can see, so we have 90 mm panel for internal walls and 120 mm wall panels for external walls. And you can see weight of wall panel is 135 kg, which can be easily lifted by 2 people. Okay, and for 90 mm it is 105 kgs. And this is just to explain you how these panels are connected. So what you have a structural skeleton, which can either be, here is what you see here. This is a steel beam column, and here what you see, this is a RCC beam column. So what you do is you put a groove, or here you weld the steel or double wire, and then that double wire is inserted into the elevated concrete. So if you can see here, otherwise you can we have videos also of installation of these panels. You can see that thing as well. And these panels, how they are connected, because they have tongue and groove joints, so they can be easily. Tongue and groove is nothing but a slide and lock arrangement. So these 600 mm or 2 feet wide panels can be put side by side, and then through tongue and groove and that rich mortar, you can connect them to create this kind of face. And to connect them with the adjoining beam and columns, you can have either this kind of arrangement. If you have steel, if you have RCC beam or column, then you have to create a groove, and then you have to put a double wire. And normally when you connect it with the column, you have a double wire at a 45-degree angle, so as to have a better connection. Okay, so always to take care of shear forces, you need to insert a double wire at a 45-degree angle. And I think it's being written here. And to have verticality and all, you need to have a U-type channel at the bottom, and on that U-type channel, you put these sandwich panel systems. So that is what is written here. And joint between these panels, as I explained you, are filled with rich mortar, and here we are using ready mix plaster, superfine. And then later you can finish this wall with putty and do the color washing. And the joints which are being created here, they are filled with anti-crack fiber. And you can see the details here as well. Whenever you have a joint, you can have this kind of T joint, or you can have a L joint. So wherever you have L joint and T joint, to have to have connection of all the walls together, you can have a double bar inserted in, so that this joint acts together in case of in the event of shaking or an earthquake, because this wall and all these walls should be tied together at the corner, so you have that kind of double wall arrangement. Advantages, I don't need to explain you. One of the major advantage of this technology, imagine replacing a brick masonry or any other stone masonry wall with this kind of wall system. So you don't require any wall, you don't require any water in this. So that is why these sandwich wall systems are also called as dry wall construction. Okay, and lightweight, as I told you, the density is quite less. So the major load in the building is of your walls only. So once you replace those brick masonry or any other walls by these lightweight material sandwich walls, naturally you save on a lot of things, which brings resource efficiency. And you get a economical, cost-effective design. Also, the being eliminated concrete, it provides better thermal insulation, better sound insulation, and energy efficiency. And being light in weight, the overall load to or requirement of the building is less. Because of this, your foundation is also cost-effective. And let me also tell you, if your lighter is the building, better is the seismic performance of the building. Now, just to give you, you just can't use these panels as it is. You require, there are certain, little bit of training, on-site training is required if you want to install these panels at the site. And the essential requirements are being written here. As you can see, the joints of panels need to be perfectly locked, because if you don't, they come with slide and lock kind of arrangement. So you have to ensure the perfect locking of these panels. If you don't lock them perfectly, so at a later stage there may be a spalling, and the panel may go out of from each other. And whenever you connect those two panels, so again, installation manual is also being supplied with the technology. In fact, with all these new technologies, they also give you the manual, user manuals, which comprises of installation manual. So here, specific, special kind of ready mix plaster is being used, which is used to fill the joint between two panels. Okay, and for leveling, you have to see with plumb, like you see in masonry wall, and to see the verticality. You have to have a U-channel, and in that U-channel you have to erect these panels. Also, to provide services and all, you need to do cutting and chiseling, and cutting and chiseling can be done as you do in in brick masonry, but here you require special tools, which are also being given by the technology provider. And then the panel, if used as a floor, these panels can also be used as floors. So when you are using it for floors, so they give the design requirements which need to be strictly adhered to. Now, let me also give you something about the design and basis. You might be wondering that this is a new technology, and if we need to do the design analysis, how do we do it? So most of the technology providers, they have their own softwares for analysis and for design. But nowadays, there are umpteen number of softwares available in the market which can be used for analysis and design purposes for these buildings. And when we are dealing with these new technologies, always nowadays we are promoting the projects on, earlier projects were awarded on item rate basis, but now it is slowly being replaced by EPS contracting system. EPS contracting system means design and build. So what you do is you give your requirement to the bidders, and they do their own design, and based on their design they build the structure. Okay, so the project was awarded on design and build basis. The agency which is executing this project is KPR Project Con Private Limited of Nasik. I think Sanjay Patkar, their MD, is also present today. And the technology provider is a very dynamic person, Mr. Ratan Singh. I think he's also attending along with his son, and they are supplying this technology, which is for the first time. Rising Japan is the name of the company, and Precast sandwich panel is being supplied by them. So this is the marriage of these two. Implementing agencies KPR and technology provider is Rising Japan, and both of them are together. They are executing this LHP at Indore. And this is just for this slide. Next few slides are for the engineers and architects. If we have to do a design and analysis of a building, we need to first of all assess the geoclimatic condition of that area, and then calculate the wind forces, earthquake forces. If it falls in a landslide prone area or cyclonic prone area, we need to calculate that cyclone load, and then accordingly we have to put that load and design the entire structure according to those loads. And similarly, for designing a foundation, you need to carry out a detailed geotechnical investigation, find out safe bearing capacity, and you need to find out the water table, water table depth, and the soil strata. And based on the soil strata and the safe bearing capacity, you ascertain the depth of the foundation. So depth of foundation is also very important. And when we talk about high-rise structure, to counter the overturning, depth of foundation plays a very important role. So here we are using just for civil engineers, structural frame is RCC steel hybrid structure, and up to plinth we have conventional foundation comprising of combined and RCC footing, and shear walls wherever we have a staircase and lift wells. And then again we need to follow strictly our codes which are there for designing for design purposes. And this map which you see here is a map of wind hazard map of our country, and this map we have taken from Vulnerability Atlas of India, prepared by Building Materials and Technology Promotion Council, that is us. And this map is also given in National Building Code, and there is a code IS 875, from where suppose this is in Madhya Pradesh, so this Madhya Pradesh falls in green, this blue region. So the basic wind speed is 47 meter per second, and based on that wind speed you can find out the wind pressure, and that wind pressure can be converted into the wind forces. Similarly, on the right hand side, what you see is the earthquake zoning map of our country, and again it is taken from Vulnerability Atlas. This Vulnerability Atlas of India is available digitally on our website as well as on Ministry's website, also on GHGC website. And whenever you embark upon any new project, you must assess the geoclimatic condition of that site or that area. And what I mean by geoclimatic condition is your hazard profile in terms of earthquake, wind, cyclone, flood, landslides, etc. So this is Madhya Pradesh, and Madhya Pradesh falls in zone 2 and 3. The entire country is divided into 4 zones: zone 2, 3, 4, 5. What you see red is zone 5. So entire northeastern region is in zone 5. A part of Gujarat region is also in zone 5, and then we have the entire Uttarakhand and Jammu Kashmir, some area is, and HP is in zone 5. Okay, that red thing what you see, and the dark yellow is zone 4. So this is zone 3, and depending upon zone, you calculate the seismic base shear, and that seismic base shear is applied across all these stories to carry out the analysis and design. And again, as I have been repeatedly telling you, that you have to carry out the design analysis as per the prevailing Indian standards. So there are codes. I will show you the list of those codes as well. Okay. Somebody is. Yeah. So just to give you a list, very quickly I will show you these are the codes for calculating the loads. These are the codes, because we are using steel as well as concrete. So all the codes for steel and RCC are listed here. So these are the codes for steel. Most important code for loads is IS 875, and all these codes nowadays are available online on the BIS website. And IS 800 is the most important code for structural steel. And for light gauge steel, IS 801 is the most important code. Then for RCC, IS 456 is the most important code. And for earthquake, 1893 is the code, and 13920 is another very important code for ductile detecting. This I will not. Yeah. So now once you have calculated the load, you need to resort to any software. These softwares nowadays, these are called computer design softwares, which are available commercially, and you can use any one of them. So StatPro, some of you might have used it. So what you have to do is you have to create. So this is the model of a lighthouse project at Indore. So this is the model which is created in the computer, and whatever loads, just I explained you, all those loads, whether it is dead load, whether it is live load is again, there is a code for live load, and depending upon the application of your building. Suppose this is the residential building, so you require 200 kg per centimeter square is the live load for residential building. If it is your, if you're designing an auditorium, the load is different than if you're designing a library or industrial structure, that live load is different. So you calculate those live load, dead load, earthquake load, and wind load, and then create these kind of combination. And you see this is quite complicated and involved exercise. You have around 13 load combination, and the worst load combination is taken for design purposes. And then you carry out the analysis, and then you design your structure. I've been using the word design. Design means size and shape of your columns, walls, thickness, the reinforcement, or whatever you require. All these things can be calculated, can be found from these CAD softwares. And thankfully, earlier these softwares, did not incorporate Indian standards, but now most of them have Indian standards incorporated. So you can just use them and get the design. And once you have the design, you have to create the AutoCAD drawings, and those AutoCAD drawings are being given to the implementing agencies, and then they implement the project based on those structural and architectural drawings. So having explained you this theory, let me just quickly show you the construction sequence again. Construction sequence is again divided into this superstructure and substructure and superstructure.
नहीं है, आप देखा है इसका मोड है जैसा लास्ट टाइप का जैसा रहता है.
So first of all, you must know how to read the structural drawing, and this just I'm showing you. This is a simple structural drawing showing you the foundation plan. And what you see, these rectangular things are the column locations. Okay, so these are the column locations. What you see these are the shear walls. Okay, so shear walls are coming wherever we have lift well or staircase well, and these are your columns. So wherever we have column, there you have a foundation plan. So from these drawings you can reading these drawings, you can create a trench plan, then you can, excavate and put the foundations and have the locations marked and those things. And for reinforcement, each column is given a nomenclature, like 1, 2, 3, or sometimes we go A1, B1 to C1. And then for the entire project, you read that column as A1, and the details of A1 is given, and you have to, refer that A1 column and their details, whether it is size, it is shape, it is reinforcement. So this is the reinforcement details. So it is just, I wanted to show you, this is the drawing, and through this drawing, you construct. So again, these are the drawings. I will not go into details of this. So once these are the foundation drawings, and then once you come to the you have to connect all these, as I was telling you, these are the columns, and all these the pedestals or columns are connected at the plinth through this plinth beam. So you have a plinth level framing plan, and through that and you have the reinforcement detail. You put that reinforcement case, do the concreting, and connect to the plinth level. In fact, I will show you the pictures of this. And for each, when you are using it or reinforcement, you have to use or you are using a steel section, you have to use a specific grade, complying to those Indian standards. So here for our footing and raft foundation, we are using M25. Okay, and reinforcement is TMT bar of FE 500. Normally, it is better to get the mixed design done. Earlier, we used to have nominal design. Nominal design, suppose you are doing M20, it is 1.5, 3, 1, 2, 4 for M15. Now that instead of that, you need to go for mixed design. So mixed design is normally done, and because by doing mixed design, you are optimizing the use of materials. So cement, sand, and aggregate in this ratio is being used in M25, and then that normally that design is done by academic institution, and then it is approved and given to the contractor. And through this, they are using the plasticizer and all, so as to have early gain of strength and other things. And this is a batching plant. Normally, when you do a project of this size, it is better to have a batching plant installed at the site. So this is a picture of a batching plant, and you can see these are the silos where material is being put and here aggregate is being put. And when you have batching plant, so you can, actually, as per your mix design, you can accurately, calculate the material and put it in the through these silos, you can put it and make the get the concrete made, and through this conveyor belt and use that concrete. So it is a good practice for better quality of concrete. You need to have a batching plant installed at the site. Yeah. Okay. So this also, let me tell you that batching plant. One thing is batching plant. When you have a project of this size, batching plant is it's not mandatory, but it's a good practice to have batching plant at the site to have resource efficiency or automation. Similarly, for a project of bigger size, after 2000 Bhuj earthquake, it was found that quality, although we have quality control, but quality is not being assured at the project site. So to have a quality assured, you need to conduct tests at the site itself. So normally for all the LHP Lighthouse project sites, we have asked the implementing agency to create our testing laboratory at the site. And at the testing laboratory, what you see here, this blue thing, these are the boxes in which concrete cubes are being cast, and then these cubes can be put for compression testing machine to ascertain the compressive strength of that concrete cube. So for each lot, you conduct tests and assure the quality of the material. Okay. Now, let me show you the pictures. So this is foundation. So when you start the project, first and foremost thing is to lay the foundation. And for laying those foundations, you have to excavate your ground and go to the desired depth, which comes through that design. So if here the depth is 2 meters, so you have to excavate 2 meters. And sometimes you encounter rocks and other kind of boulders, and also you need to use mechanical excavators and other kind of cutting arrangements to create this kind of pits. So once you create these pits, you go to those structural drawings which I showed you, and through those structural drawings, you carry out the layout and putting all the locations of those foundations, their central line and all those things, and then you start casting the foundations. So this is how it is being done. This is the ground being excavated. And now you see, because I showed you, so this is called, isolated footing means, if you have a rough foundation, then the entire area is being covered. Here, isolated footing means for each column, you have separate footings. And wherever the 2 columns are nearby, then you combine these 2 footings. So then it is called combined footing. So here, these are isolated footings. So first, you create a PCC to create a, uniform platform. And over that, you put a reinforcement cage and put an isolated footing. So this is PCC, it is called plain cement concrete for leveling the undulating ground. And over this, what you do is you put this reinforcement branch. This is so here you have laid this PCC and over. So again, all this is marked from that structural drawing which I showed you. Okay, through that structural drawing, you mark those center points and all those things. Okay, and when you mark the center points, it is not that you mark the center points like this, then that diagonal is diagonal. This diagonal also need to be calculated, and the diagonal It has to be perfect. Otherwise, your beam and column may go here and there. So it's not that center line measure like this or like this diagonal. All spaces are being measured, and then layout is being done. So over this PCC, what you do is you put the reinforcement cage. So you can see here, this is the reinforcement cage of typical isolated footing. So this is how, so this is reinforcement cage, and then this is now ready for, concreting. Now we will do the concreting, and then over this is that column which we are talking about. This column will go up to the plinth level. So these are the isolated footing, and wherever we have a staircase, well, there we have a raft foundation, and then we have a shear wall kind of thing. So here we have shear wall, it goes up to the plinth, and at the plinth level, we provide a plinth beam. So you can see here, so these are those columns which we are talking about, and wherever we have a staircase, well, we have that other kind of foundation. So in this, you can see this right-hand side, these are the columns, isolated footings, and here this is a, shear lift well, lift and staircase well is done with shear wall. And you might be wondering why we are providing shear wall here. Because, during 2001 earthquake, it was found, people were escaping from staircases, and most of these staircases fell. Okay, so they were damaged very severely, and it was found that the staircase was the main region of failure of few buildings. And then it was decided, it was thought that whenever you have because there are always heavier loads at the staircases, so you can have a shear wall kind of thing, so that staircase or lift case well acts together in a box kind of action during shaking. And here what they have done, because this is going up to plinth level and it is around 2 meters. So over that raft, they are putting the shear wall, and for waterproofing, they are putting this quota stone. Okay, so this is the new kind of thing which is specified in this project. So you have a raft, and then this exposed concrete surfaces are, being put with this quota stone here for waterproofing, so that there is no ingress of water. So this is a typical layout you can see. So what you see here, this tapered is that isolated footing, and over that this column is coming, and this column goes up to the plinth level, you can see here. So this is a typical layout. And what you see here, so here this was the pit, and here this was the isolated footings and shear wall and those things, and these are the columns. And once you reach the ground level, which is called a plinth, you fill this with the excavated soil. Whatever soil you excavated, that is filled back again here. And then once you come at the plinth level or at the ground level, you put this. So this is called plinth beam. So this is the reinforcement of plinth beam, and now we will do the concreting of this to create a plinth beam. And as I've been explaining you, it is a very good practice to connect all the columns at the plinth level together to this plinth beam. Again, idea is to have a better seismic resistance of better seismic performance of your building. Okay, so backfilling is done, and after doing that backfilling, again, see, this sentence also has a lot of meaning. You just can't do a backfilling just by putting the soil again. Backfilling has to be done in a proper fashion, and there are specifications given by CPWD. You have to do it in layer by layer. You have to sprinkle water. You have to do the proper compaction, and then come up to this, so that this is compacted properly. Okay, and after reaching here, you do this plinth. And once you come at the plinth level, so wherever you have column, now you will have over this steel columns. So for steel columns, you have to grout these bolts, because again, in the next slide, I will show you that column will come with a base plate, and here there will be, and then on already there will be holes on that base plate, and then the already grouted nuts over that nuts, that base plate will be put with that column. Okay, so this is the kind. So there is a template for this base plate. So based on that template is being put, and then these are marked. The locations are marked for grouting those bolts, so that there is no misplacement and all. And always this, what you see here, these are the sleeves for having the better grip, and for it is grouting is being done. So normally the bolts are put in these kind of sleeves. Okay, so these are those bolts which are talking about through this, and you have to see the plumb. Plumb is also very important, so that no column should go out of plumb. Otherwise, when you go such a high rise, by the time you reach the upper story, the column will go out of plan. Okay, so this is that when you come at the plinth level and with the casting of plinth beam with this template, you put mark the locations on those boards, and then on the sleeves are put, and then you do the grouting. You can see here. So these are this, and the curing is being done with this. So here, this is a well, and this is your plinth. And then, this is that structure will come like this. I will show you again in a picture. So once you have come to this level, then what you have to do is you have to erect these already manufactured factory-made beam and columns you put, and then you do the walling. Okay, and this I will just wanted to show you that these nut and bolts are also special nut and bolts, and they are also designed so that this column should not overturn during high wind or during other accidental loads. So these nut and bolts are of this kind, and they are also designed for their height, the threaded length, and all those things. Okay, and then you have to have this kind of L kind of arrangement, so that they don't they provide sufficient resistance for overturning. And then, when you connect column to beam, there are a number of connections, and each connection, when you connect, so there are a number of connections, you can have this kind of connection, you can have this kind of connection for, column and beam, you can have corner column and beam. So all these column and beam are specially designed, and there are drawings given. Sometimes they are connected through flange and web to have, shear and axial shear and flexure resistance. If you want to have only shear connection, then you connect it only at the flange, or otherwise you can connect it with flange and web. You have to have a cleat angle and all those things. So all these things can be read from the drawing, and so these are those connections to column, how to connect column to column, because these columns come in a specific size. These columns are of 6 meters. So you have to connect one column to other column. So how will you connect? So those, these are those column connections. So if you want to connect column to column, so this is that connection we are talking about. And these column connections, if they are subjected to shear and fracture, then you have to connect it through flange and web. If they have only, shear connections, then you have to connect them only at the flange or web link. Okay, so these are those connections. Similarly, you have to connect beam to column. So these are those details. So this is a beam, this is a column, and how beam and columns are being connected. So at a flange and at a web portion, they can be connected, or they can be connected only at a flange level. Okay, then for steel also, I will not go into this. For steel also, like we are talking about RCC. All of you are aware of RCC reinforcement concrete. So you say this is M25 or M20. The water cement ratio should be this much. The minimum cement quantity should be this much. Similarly, when you are using a steel section, so steel section and all these dirt, bolts, grooves, whatever you are using, threaded length, all these things should strictly comply to the various codes which are available. So all these connections, their specification of steel, whether it is mild steel or the yield strength of steel, their percentage of different components, all those things need to adhere to the specifications given in structure. So this slide, the next two slides shows you those things. So as you can see, built-up I section should conform to IS 800 and 7205. Similarly, all base plates. So again, base plate of required thickness, what should be the specification of steel, what should be its yield strength, and all those things need to be strictly as per Indian standard. Similarly, anchor or holding down bolts, the bolts which I showed you, they should be of a specific grade and conforming to the Indian standard. Okay. So now let me come to the steel column. So once you have done the foundation, then you come to the structural drawing of column. And this, as I was telling you, that each column is given a specific nomenclature. And so we have divided all the columns which we have in 3 or 4 categories, three categories here: C1, C2, C3. And you can find out where is C1, where is C3, what are its dimension, what is web and flange length from these drawings. Okay. Then, let's after finishing the skeleton, you go to the slab, and slab, as I told you, a special kind of slab. It is a deck slab. So this is that profile I was talking about. So this is a steel deck sheet profile. That sheet is 0.9 mm thick, and the profile is of like this. So this is again, these profile sheets are available in the market, and you can just take them and then put them, and over that you put the nominal reinforcement, which is shown in this drawing, and do the 75 mm screed. Okay, and after doing that, your deck side. So first you lay the profile sheet. Over that you put the reinforcement, nominal reinforcement, and you then you do the screed concrete. So this again a structural drawing of typical floor framing plan when you are coming to a floor. So you need to see the this drawing particularly what you see arrows and all here. These are the slopes. Okay, so particularly when you are doing a roof and also the slope directions need to be added to, and particularly when you do this kind of profile sheets and all those things need to be seen, and they should be properly laid. Okay, so for that you have a drawing, and you can do it from that drawing. Once you have done the skeleton with this, and then you have to start erecting the prefabricated sandwich panel systems. So those prefabricated, what you see green, so this is one portion, this is another portion. You can see there are L joints, there are C joints. So all these are customized beforehand, and all these are again numbered in the factory, and when they are brought to the site, depending upon the number, you keep installing those panels here, and so they are they are shown with different colors, and so by just picking that color you pick that panel and then start erecting those panels. Okay, and you have a column here, and you have this panel, and thickness of this panel is 120 and 90 mm. So you have this flange or web of a steel column coming outside. So that is being concealed with another panel, a small panel of 60 mm, and this is how it is being concealed. You can see here. So if you have it at mid corner, if you have it at the mid corner, this is a mid corner. So you conceal it like this because the flange of steel column will come like this. So this need to be concealed, and if you have it at the corner, then you conceal it like this. All these details can be found from the drawings, and all these panels are being manufactured in the factory and being supplied. Okay, so you can see here that this is again whatever I explained you is written here. How these sandwich panels are being erected at the site. You can see first you transport them to the site, and then you erect the built-up section. So first foundation is done, then sandwich panels and steel sections as per the drawing, then erection of built-up sections for structural frame, then decking sheet. So first foundation, then over that foundation you are putting this structural skeleton system. Over the structural skeleton system you are putting slabs or floors, and over that floors you put these sandwich panel systems. And once you put the sandwich panel system, after that you start putting the services by cutting the grooves through chiseling in those panels. This is how it is being done. You see. So this please switch off your mic, please. So I think it is understood by all of you. So there can be two variants. Through this drawing, I wanted to show you here. These sandwich panel systems are used with the RCC beam and column, and here in this project we are using steel beam and column. So this horizontal member is beam, this is column. So in between you are putting this prefabricated sandwich panel system. Otherwise, you can have RCC beam and column, and this is how this is that panel I'm talking about, and they are being put side by side to create the entire wall. And you can see once this is how regarding services. So any service like you do in masonry buildings or conventional RCC frame construction, similarly you can do here, but you use a special tools because softer material is a calcium silicate board with elevated concrete, so it can be very easily chiseled, and then you can put any kind of services, any kind of sanitation or sanitary and plumbing installation. So this is a finished building with prefabricated sandwich panel system, and you can have any kind of WC cistern, your wash basin, and all those kind of things, bathtubs and all. So they are compatible with existing services, MEP services. So in this particular project, if I have to give you the idea of finishing items, those finishing items are we are using pressed steel door frames with the plug shutters, and for wet areas we are using PVC door frames, and for windows UPVC frame with glazed and wire mesh shutters are being used. Vitrified tiles are being given in all the floors in rooms and kitchens, and for wet areas, anti-skid ceramic tiles are being given, and common areas because they are being used frequently, quota stone flooring is being.
Sir, how many more slides we have?
4.
Okay, because the internet connection in Indore is very weak, so we are trying very hard to connect it nicely. So if we can just, yeah.
4 slides बस हो गया. Last few slides. Okay, great. So these are other infrastructure facilities. As I told you that the project is a lighthouse project, and we are showcasing not only the technology but the best practices. So all best practices towards sustainable developments are being included, whether it is renewable energy, whether it is wastewater management, whether it is LEDs or other kind of things. All those things, stormwater drains, then rainwater harvesting, solid waste management, all these things are being included in this project. So that was the last slide, but let me just show you the progress. You can see here. You can see. So this is that foundation which I explained you in detail. So what you see here is the foundation and those columns up to the plinth. Now once we have reached to the this is the foundation point. Okay. Now this is the plinth. At the plinth level, the casting of plinth is being going on. And once you have come up at the plinth, what you see, this reinforcement, this is the reinforcement of shear wall. So always remember, we are distributing between the common areas. Wherever we have lift, we are having this kind of shear wall kind of thing. And other places we have only beam and column. Once you have come to the plinth, you see, you start erecting these steel columns which I was showing you, and wherever you see this kind of thing here, the beam will come. So for that, it is being put like this, and you will insert a beam here and connect it with nut and bolt. So having reached to the plinth, you start erecting these columns, and then you see. So these are those beam and columns with these base plates. This column comes with a base plate, and that base plate is inserted with the already grouted bolts, which I explained to you. So once you have done this, you have beam and column, and you connect these things like this. So here the beams are being connected. So now this is that skeleton, or this skeleton is called structural steel, structural system. So this looks like this, and now this, after this you will put a tech sheet. So that is the profile sheet we are putting, and over this profile sheet we will put this reinforcement, and then we do the screeding. You see, so through these pictures already, these are from this project site itself. So this is the screed concrete, and now having erected that structural system, you are doing that floor. Once you have done the floor, you start putting these prefabricated sandwich panel system. And as I was telling you, this is a 610 mm wide. So this is at these junctions there you put a anti-crack tape, rich mortar, and then do the putty so that they are perfectly placed. So this is again a view you can see here, and you can see this sunshade is also of this panel only. So this is being put like this. And all services and all you can put once you have done this, because it's a deck slab. So here there is a provision of false ceiling, and so this false ceiling is being done. So this is an overview of this project. You can see here. So that's all. So you can, I think you must have understood that technology is hybrid, comprising of steel beam and column with prefabricated sandwich panel system for walls and a deck slab for the. So this is the view, and now we'll be taking you to the project site, and I will ask. Yeah. So this is the last. In fact, you all can access our website, which is gsdc-india.gov.in, and you can see the live status of all these projects on your computer or on your laptop. So you can just note down this, and in case of any query or anything, you can always write to us. My email ID is also written along with the ministry's email ID, and we will get back to you. And we are uploading photos on a daily basis of all these projects so as to ascertain the progress of these projects. So you can all see the progress by visiting this website. So that is all. I will answer the question. Answer we'll have at a later stage. Now, Manish, if you can take them to the virtual tour of LHP site, we can explain them at the site. the works which is happening, if you are listening to me. Manish?
Thank you very much. We'll connect the cameras, which is showing the live work at the site. And I'll request you and maybe Kashinath can help us describe the work which is going on. So we have two cameras, sir. One, we are showing the full view of the project. And we have one close-up camera which is showing the actual work which is going on in 1 or 2 blocks. So this is the final view, and maybe Kashinath can explain more.
So as you can see here, I think I just explained. In fact, I also showed you this is a live picture. This is a live webcast which is being done by Kashinath. Kashinath is a representative of technology, of a contracting agency. So this is one block. What you see here, those steel structural systems that I was talking about, and that white thing, what you see is prefabricated sandwich panel system. Okay. So it's a bird's eye view, or you can see the overall view of the entire project. And Kashinath, this is block A, or these are all the blocks, all the 4 blocks shown here?
Yes, sir. It is block 2.
This is block 2. So this is the, I think, as I showed you in the first drawing, the layout is it's a long rectangular, oblong kind of layout. So most of the buildings are in this direction. So I think this is self-explanatory. And what you see here at the top, this is that shear wall I was talking about. So wherever you see this, there is a variation. Here you have columns, here you have this shear wall. So that shear wall is nothing but a RCC wall, reinforced cement concrete wall. So wherever we have lift well, so there are provision of lift because it is S+8 structure. And in addition to lift, there are 2 staircases. 1 staircase and 2 lift well, or 2 lift well and 1 staircase. Kashinath.
Yes, sir. Thank you. First of all, I welcome all to Indore, LHP Indore, and good afternoon all. हम लोग यहाँ पर देख रहे हैं सीरीज बिल्डिंग नंबर 2, 3, 4 इन लाइन, और ओवरऑल सभी बिल्डिंग में पीईबी का काम चल रहा है. और यहाँ पर हम लोग देख सकते हैं कि बिल्डिंग नंबर 2 में इरेक्शन का भी काम चल रहा है, जो भी अभी क्रेन में बूम एक्सटेंशन कर रहे हैं. बूम एक्सटेंशन करके कॉलम इरेक्ट करेंगे. जैसे ऊपर में कॉलम पहले रख दिया है, वहाँ से फिर कॉलम इरेक्ट करेंगे. और यहाँ ईपीएस पैनल का भी काम चल रहा है बिल्डिंग नंबर 2 में. हम अगर जूम करके देखेंगे तो बिल्डिंग नंबर 2 में हम लोग देख पाएंगे ईपीएस पैनल का काम एकदम क्लोजली देख पाएंगे. उसको वहाँ क्लोज कर दीजिए उसको.
कशिनाथ, आप बोलते रहिए और हम लोग जूम करने की कोशिश कर रहे हैं. थोड़ा इंटरनेट का कनेक्शन का इशू है, बट we'll ट्राई जूम करके कितना दिखा पाते हैं.
ठीक है सर. यहाँ पर हम लोग जो ईपीएस पैनल का काम करते हैं, इसका एक पर्टिकुलर मेथोडोलॉजी है. इस मेथोडोलॉजी हम क्या करते हैं कि एक वॉल जो है, इस वॉल का सबसे पहले तो शॉप ड्राइंग तैयार करते हैं, क्योंकि ये पैनल जो आते हैं ये 610 बाय 2440 हाइट के आते हैं. तो ये टोटल हमारे हाइट के हिसाब से मैच नहीं होंगे, तो हमारे यहाँ पर इसको शॉप ड्राइंग बनाया जाता है. उसके हिसाब से फिर इसको स्टैगर्ड जॉइंट के हिसाब से इसको प्लेस किया जाता है. और ये जो भी पैनल्स वगैरह है, इसके लिए पहले लेआउट करके फिर पैनल को वहाँ पर प्लेस करना, पहला पैनल लगाने के बाद में उसको लॉकिंग करना. तो ईच एंड एवरी पैनल लॉक होते हैं, और उसी में डोर विंडो जहाँ पर आती है तो विंडोज भी प्री स्ट्रेस विंडो है, तो उसी में डोर भी उसी में फिट हो जाता है. तो हम लोग देख रहे हैं सब यहाँ पर पैनल्स जो है एक पर्टिकुलर शेप में पैनल्स को काटकर हम लोग यहाँ पर लगाए हैं. हम लोग जो पैनल जॉइन करते हैं तो ये पॉलीमर मटेरियल यूज करते हैं इसमें पैनलिंग में. यहाँ पर बूम एक्सटेंशन का काम चल रहा है सर, हम लोग देख पा रहे हैं.
काशीनाथ, आप क्रेन से कुछ करना चाह रहे हैं क्या? कुछ दिखाएंगे अभी?
नहीं सर, अभी क्रेन एक्चुअली उसका बूम एक्सटेंशन हो रहा है. बूम एक्सटेंशन होने के बाद में ही वो इरेक्ट हो पाएगा.
तो हम लोग ब्लॉक में देखते हैं जहाँ पे कुछ काम चल रहा है ना अभी पीईबी का.
यस सर, ऊपर ईपीएस पैनल का काम देखेंगे हम लोग सर.
काशीनाथ, ये भी बताओ, ये सनशेड भी उसी का है ना? सैंडविच.
यस सर, ये सनशेड भी हम लोग ईपीएस पैनल में लिया है. 450 mm उसका कैंटिलीवर निकाला है बाहर, और दोनों साइड में 150 mm का बेयरिंग दिया है इसमें.
अच्छा काशीनाथ, थोड़ा ये बता दो इन लोगों को कि स्टील के साथ ये पैनल कैसे कनेक्ट हो रहा है.
एक्चुअली स्टील के साथ में पैनल कनेक्ट होने के लिए हम लोगों ने वहां पर बार वेल्ड किए हैं, एक अलाइनमेंट में बार वेल्ड किए हैं. और ये जो पैनल हम लोग लगाते हैं, उसको प्लेस करते हैं, उस समय उस बार में उसको इंसर्ट करते हैं। हम लोग अगर
उस बार
कॉलम
का
देख पा रहे हैं तो कॉलम में 3 डॉट दिख रहे हैं यहाँ पर, देखिए
हाँ
जहां पर हम जूम कर रहे हैं वहां पर 3 डॉट दिख रहे हैं, वहां पर हमने क्या किया है, बार वेल्ड किया है, उस बार को हम लोग उसमें ये कर देते हैं इसमें।
अच्छा, वो बार क्या है, TMT बार है या
यस सर, टीएमटी बार है।
कितनी डाया की है? डाया
वो 10 mm डायमीटर का टीएमटी बार है, 3 इंच लंबाई में बार है। वो
Very
बार हम लोग यहाँ पर वेल्ड कर दिया है, उसके अंदर में हम लोग ये पैनल फिक्स कर देते हैं, तो ये स्टील कॉलम के साथ में फिक्स होता है। इसके
हाँ।
अलावा एक एस बॉन्ड करके एक मटेरियल आता है जो स्टील और ईपीएस पैनल का एक अच्छा बॉन्ड तैयार होता है, वहां से लीकेजेस वगैरह नहीं होंगे, इस तरह से इसका बॉन्ड होता है। और बाकी जो बीच में हम लोग जो पैनल ज्वाइन कर रहे हो पॉलीमर मटेरियल यूज कर रहे हैं इसमें।
Very nice.
यस
So I think it is explained very well by Kashinath. So you are seeing the pictures of the project site. Anything else you want to show, Kashi?
यस सर,
हाँ।
एक्चुअली हर लोगों के दिमाग में ये आता होगा कि ये कॉलम जो है, ये कॉलम का बाद में करेंगे क्या, इसको फिलअप किस तरह से करेंगे, ये क्या ऐसे ही दिखेंगे, ये काफी कॉमन क्वेश्चन है इसमें। तो मैं एक दूसरे कैमरा व्यू से आपको दिखाना चाहता हूँ, थोड़ा सा कीजिए दूसरा व्यू। हाँ वो वाला व्यू सही हो जाएगा, मतलब काम अच्छा होगा जो पहले मैंने देखा था।
Yes.
कॉलम हमने यहाँ पर फिलअप किया है। हाँ इसको थोड़ा जूम कर देना नीचे।
Very good.
ये देखिए, अभी नीचे का पैनल देखेंगे हम लोग तो ये पैनल फिलअप किया गया है, इसी ईपीएस पैनल से ही कॉलम को फिलअप किया गया है। पूरा वॉल सरफेस जो है वो एक लाइन में आ जाएगा। सभी लोग देख पा रहे होंगे सभी इसमें सभी।
हाँ, ये देखिए यहाँ पे अगर ये पाउस ले होंगे, देखिए आप यहाँ पर ये जो क्या है, ये इसका फ्लैंज, ये कहलाता है वेब, ये वेब दिख रहा है यहाँ पे, इन्होंने देखिए व्हाइट से ये भर दिया है। इज इट करेक्ट काशीनाथ?
यस सर, इट इज करेक्ट। सभी कॉलम और बीम के गैप्स है इसी तरह फिलअप हो जाएंगे, तो बाहर का सरफेस जस्ट लाइक हमारा जैसे कन्वेंशनल वॉल दिखता है उसी तरह से वॉल दिखेगा। और फिर इसके ऊपर में हम लोग एक वाटरप्रूफिंग लिक्विड से स्प्रे करेंगे, उसके ऊपर पेंटिंग करेंगे।
Good afternoon, Dr. Agarwal. How are you?
I'm fine, Girish, fine. I think we have a technology provider as well. So you want to say something?
I'm currently in Dubai right now. As you can see, we are at a factory. We have a very big project going on here. Mr. Kasba, आप अपना mic mute करेंगे please. Mr. NP Kasba. Can you hear me?
Yeah, sure. Go ahead. If you quickly want to add something to your technology or your efforts.
Yes, one of the main things I would like to suggest, which Mr. Kashinath has suggested and explained very well. India के अंदर most people think panels के अंदर U channel and C channel ही लगता है. Without that, it's not possible. ऐसा नहीं है. Actually, when we use the panels with the channel, with the C channel, U channel framing के लिए, that leads to a weaker section and to a weaker structure than what we have using our technology. For that, because हमारा panel goes directly into the beam, directly into the floor. There is no gap of that 1 mm between channels and that movement, so the cracks do not occur. Another thing is, which does happen, as he explained, we use very good jointing compound. Besides the jointing compound, we have 3 layers of tape. So we have a regular mesh tape, there's a gel version, and then on top we put a special putty. So the problem of cracks, which many people are worried about in India, that will never happen. Plus our boards are using calcium silicate instead of fiber board. So that is another thing which is very good for fire and water retention. Also, there is no bending, and hopefully this project shall go ahead and be the highlight of a lighthouse in India.
Okay. Thank you, Girish. Kashinath.
Thank you.
Kashinath, anything else you want to say?
काशीनाथ जी, मुझे एक चीज समझाएंगे क्या?
सर बताइए सर।
मुझे ये जानना था कि हम लोग फाउंडेशन जो करते हैं,
यस सर,
वो कन्वेंशनल मेथड से करते हैं, बताया गया।
यस सर।
उसके आगे फिर ये कैसे जोड़ते हैं फाउंडेशन के ऊपर स्टील?
फाउंडेशन के बाद में अप टू प्लिंथ लेवल हम लोगों ने आरसीसी कॉलम लिया है। इस टफ कॉलम के अंदर में फाउंडेशन बोल्ट डाले गए हैं।
मतलब एंकरिंग की गई है।
हाँ, एंकरिंग की गई है। इट इज अप टू 900 mm 1500 mm ऐसे उसको एंकरेज किया गया है फाउंडेशन बोल्ट को। उसके बाद में उस पे ऊपर फाउंडेशन प्लेट रख के उसके ऊपर कॉलम रखा गया है बेस प्लेट के ऊपर।
तो हम उसके बाद उसमें वेल्डिंग भी करते हैं।
वेल्डिंग नहीं, एक्चुअली ये पीईपी स्ट्रक्चर है, ये प्री फैब्रिकेटेड स्ट्रक्चर होने के कारण फैक्ट्री में ही ये बन के आता है। यहाँ पर हम लोग डायरेक्ट उसको लगा के बोल्ट टाइट कर देते हैं और उस बोल्ट का फिर हम लोग टॉर्किंग चेक कर लेते हैं उसका। सर
ठीक है सर, थैंक यू। अच्छा सर, ये जो वॉल पैनल हम लोग लगाते हैं,
यस सर।
इसमें फिर प्लास्टर करना पड़ता है?
नो नो नो, कोई काम नहीं है सर, प्लास्टर का काम नहीं है। अंदर बाहर से हम लोग इसको पुट्टी कर देंगे, पुट्टी करके पेंटिंग कर देंगे। बाहर के
तो
साइड
इसमें
में
सीपेज का
इंटीरियर
प्रॉब्लम
कलर
नहीं
का
आएगा?
सर सॉरी,
सीपेज का कोई प्रॉब्लम नहीं होगा ना?
सीपेज नहीं
सीपेज
नहीं, एक्चुअली बाहर के साइड में एक क्लियर एक कोट मारा जाता है इसका वाटरप्रूफ कोट का, जिसके कारण अंदर के साइड में सीपेज नहीं आएगा, जो डैम्पनेस वगैरह कहीं पर भी कुछ नहीं आएगा इसमें। और ये सिलिकेट बोर्ड होने के
थैंक यू
कारण
सर।
इसमें डैम्पनेस भी नहीं आएगा।
अच्छा, प्लम्बिंग का और इलेक्ट्रिकल का कंडूट कहाँ पे, वॉल में रहता है कि स्लैब में रहता है?
नहीं नहीं, प्लम्बिंग जो है हम लोग वॉल में प्लम्बिंग किया है, और स्लैब से जो इलेक्ट्रिकल कंड्यूट्स हमने रन किए हैं, हमने वॉल में उसको नीचे उतारा है। और वही जैसे हम लोग कन्वेंशनल सिस्टम में ब्रिक वर्क करते हैं, ब्रिक वर्क में जैसे रिसेस करते हैं उसी तरह से इसमें भी रिसेस किया जाता है। हम लोग खाली इसमें टूल यूज करते हैं, कटिंग टूल, जिसके कारण कैल्शियम सिलिकेट का बोर्ड आसानी से कट हो जाएगा। उसके बाद में नीचे से चिजलिंग करके हम लोग उसको डीप रिसेस तैयार कर देते हैं।
काशीनाथ,
यस सर।
एक इम्पॉर्टेंट चीज इनको बता दीजिए कि हमारी फैक्ट्री में 10,000 लीटर का वाटर टैंक इसी पैनल का बना हुआ है, और उससे हम फैक्ट्री चला रहे हैं। तो उससे मालूम हो जाएगा कि इसकी वाटर प्रूफिंग कितनी स्ट्रांग है।
आप ही बताइए,
सवाल ही नहीं।
आप ही बताइए रतन सिंह जी। अरे यू आर देयर, मोस्ट वेलकम।
हाँ, थैंक यू वेरी मच।
Ratan Singh ji, one, he's a old young man who is very aggressively pushing this technology. Why don't you explain that? Because you will explain it with a lot of passion.
चलिए, आपने मुझे एक आज नया टाइटल दिया है, तो मैं आपको बता दूं, आज से मैं आपको प्रोफेसर अग्रवाल बोलूंगा। अब आप डॉक्टर नहीं रहे, उससे आप फर्दर प्रमोट होके प्रोफेसर हो गए। आज मैंने आपका लेक्चर बिल्कुल साइलेंटली और बहुत ही ध्यान से सुना है। इट इज वर्थ गोइंग टू एनी यूनिवर्सिटी। इट वाज वर्चुअली, वो सागर में गागर वाली बात है। मैं ये कह रहा था सर कि जो पैनल्स हम लोगों को क्या है, इनहेरेंट तौर पर एक हिंदुस्तान में एक साइकोलॉजी है, हर चीज को कोशिश करते हैं हम कि चीज गलत है, उसको ठीक बनाने के लिए हमको बहुत कोशिश करनी पड़ती है। मैं आपको बता दूं कि मेरा अनुभव इस इंडस्ट्री में 11 साल का है। मिलियंस ऑफ स्क्वायर मीटर्स हमने यूज किया है। विला, जो सिंगल फ्लोर विलाज होते हैं, उससे लेकर 60 मंजिल 65 मंजिल तक की बिल्डिंगें हमने इससे बनाई हैं। और आउटर इनर सब जगह यूज हुआ है। प्लम्बिंग नॉर्मल प्लम्बिंग सिस्टम है, उसमें कोई दिक्कत नहीं है। आप सिर्फ इतना करिएगा कि जो छेने हथौड़ी से लेके हम पाइप डालते हैं वो ना डालिए। जहां आपने छेनी हथौड़ी चलाई उससे पैनल डैमेज हो जाएगा उसकी सरफेस को। इसलिए आप मेहरबानी करके कटिंग मशीन, जो नॉर्मली वुड कटिंग मशीन आती है, उससे आप झिरी बनाइए, उसमें पैनल लगाइए, उसमें पाइप लगाइए, उसमें बॉक्स लगाइए, कोई दिक्कत नहीं होगा। और उसके बाद उसको सील कर दीजिए नॉर्मल ग्राउट से, जो ग्राउट आपको मिलता है इसके साथ, और यू विल हैव नो प्रॉब्लम एट ऑल।
ओके ओके, वंडरफुल वंडरफुल।
ठीक है सर।
यस, थैंक यू सर रतन सिंह जी। काशीनाथ कुछ और बोलना है? अदरवाइज वी विल आस्क देम टू आस्क क्वेश्चंस। रतन सिंह जी आप भी रहिएगा, कुछ क्वेश्चन करते हैं
जी, मैं
अगर।
रहूंगा।
थैंक यू सर।
So Manish, if can we take questions now, or we have something else to add? Manish?
Sir, we have few questions on the chat box. If you want to go through one by one.
Okay, I will
otherwise we can open the floor for question answer.
Okay, so what I will do, I will just read the chat box, and Ratan Singh ji, please help me out if there is some question. So first question is, what is the cost comparison between conventional technologies and these technologies proposed for the Lighthouse project? So just for this Lighthouse project, this technology is coming cheaper than the conventional. But I will ask Ratan Singh ji, because he has done plenty of buildings in India. Cost comparison पे थोड़ा बताएं रतन सिंह जी।
सर हमने पहली बिल्डिंग जो एनबीसीसी के लिए किया था दिल्ली में, और उसमें बड़ा स्ट्रांगली मॉनिटर किया था 11 लोगों की टीम ने, जिसमें सीपीडब्ल्यूडी के इंजीनियर भी थे। उन्होंने जो कॉस्ट कंपैरिजन किया उसमें उन्होंने 17% कॉस्ट सेविंग दिखाया है, डायरेक्ट कॉस्ट सेविंग मटेरियल टू मटेरियल। और उसके बाद उसमें 11% उन्होंने एक्स्ट्रा लिवेबल एरिया है। तो टोटल जो टाइम कंज्यूमिंग इंटरेस्ट फैक्टर वो सब मिला के उन्होंने 37% जो है इसमें प्रोजेक्ट कॉस्ट को लोअर दिखाया है। तो अगर आप नॉर्मल कंडीशन में भी देखें जिसमें आम आदमी इंटरेस्ट फैक्टर और ये टाइम फैक्टर को इतना ज्यादा कंसीडर नहीं करता है इंडिविजुअल हाउस ओनर, तो मैं उसको कह सकता हूं कि इजीली हमको 25 से 27% के बीच में कॉस्ट सेविंग है।
Wonderful, wonderful. And there is no water required for this wall.
There is no water requirement, sir, and the time saving is a great saving. And also one hidden factor which nobody is considering, जब भी कभी आप घर बनाते हैं 10% का मटेरियल लॉस होता है जो आपको दिखता नहीं है। आप रोड़ी डालते हैं, बदरपुर डालते हैं, सीमेंट के बैग डालते हैं, जब वो सब चीजें आप इकट्ठा करेंगे आपको देखिएगा 10% आपका मटेरियल लॉस होता है। ये प्री बिल्ट है, प्री कास्टेड है, प्री मोल्डेड पैनल्स हैं, आपको दीवार पे प्लस्तर नहीं करना है, आपको कोई चोरी का डर नहीं है सीमेंट की का, बदरपुर कितना मिला दिया, बदरपुर कितना कम हो गया, वो सब कुछ नहीं है इसमें। There's a huge difference between this technology and the conventional technology. Even I would say AEC block has no matching. AEC block I always consider is just another bigger brick and nothing else. So I do not know why people think of AEC block as a substitute for wall. They should strictly migrate directly from brick wall to this wall.
Okay. Okay. Thank you. Thank you. Dear all, Manish, this is for you. Please share link of this online webinar. Acha, to kuch nahi. Acha, there is very good question. I think must be some structural engineer asking. So I will answer this. He is asking that special provisions to be incorporated regarding beam column junctions for ensuring adequate ductility. You are very right, Mr. Aap is saying 1893 and 13920 are for RCC structures. So here we are taking IS 800. And in fact, I showed you the drawing where I was trying to tell you that that connections depending upon, you have shear connections, flexure connections, and shear and flexure connections. Okay, so that way you can have ductility. So strictly we are following IS 800. And also let me share with you, now we are very soon we are coming up with a ductility code for steel structure. It is already at a draft stage. Next question is, there is no more, there is no other question.
Achha. It's okay. I would like to just show something. Somebody had asked a question.
एक मिनट, एक क्वेश्चन और है. I think रतन सिंह जी, ये this question you need to answer. I would like to know about the safety aspect from ducats. Is it easy to break since it is being lightweight?
Okay, very good. अगर आप मेरी वेबसाइट पे जाएं तो हमने लाइव डेमोन्स्ट्रेशन उसमें दिए गए हैं, सारे लाइव हैं. And we have tried to break a wall with a 25 kg hammer, and 4 people by rotation has hammered this wall for 32 minutes, and we could not break the wall, we could not make a hole in the wall. This is the impact condition. And if you see this, जी बोले,
दिन भर बैठे रहते सोचे, कोई पूछता ही नहीं होगा उसको.
अरे भैया आप लोग थोड़ा बंद करिए. He is speaking. Please speak. Yeah, please. Please, Ratan Singh ji, go ahead.
तो मैं ये बोल रहा था सर, इसकी जहां तक ये पॉइंट मेरे दिमाग में हमेशा था कि इंडिया में हम लोग सोचते हैं कि दीवार के साथ चारपाई भी लगाएंगे, सोफा भी लगाएंगे, कहीं दीवार ही गिर जाए, पैनल एक चीज है. ऐसा कुछ नहीं है सर. वी हैव ट्राइड इम्पैक्ट, और इसका बेंडिंग स्ट्रेंथ और इनहेरेंट स्ट्रेंथ इतनी है, 11 लोगों को हमने एक पैनल पे खड़ा किया हुआ है. वो सारी चीजें, वो सारे डेमोन्स्ट्रेशन आपको हमारी वेबसाइट पे मिल जाएंगे. उसके अंदर वीडियोस हैं, आप खुद अपनी आंख से देखिए कि हमने 800 केजी की कार उस पैनल के ऊपर खड़ी की हुई है, एंड नथिंग हैपेंड. इट्स अ वेरी स्ट्रॉन्ग मटेरियल. इट डज नॉट नीड एनी एक्स्ट्रा सपोर्ट फॉर एनी काइंड, and you can be sure it is far stronger than the brick wall. Brick wall में आप एक ईंट निकाल लीजिए, दीवार गिर जाएगी. इसमें आप कुछ नहीं निकाल सकते। आप कोशिश करिए, मैं आपको बिल्कुल इनवाइट करता हूं, आप आए साइट के ऊपर, हथौड़े लेके खूब तोड़े, अपनी तसल्ली से तोड़े। अगर नहीं टूटेगा तो फिर मुझे बताएं कि क्या फायदा है।
Thank you. Another question for you is, what are the limitations like nailing and shifting of service points? That's a good
Okay,
question.
there is absolutely no restriction. My suggestion is that whenever you do such thing, kindly make sure that you mark the place and then thereafter you do the normal nailing without any hesitation. Absolutely. हमने एक वेबसाइट के ऊपर एक और वीडियो डाला है जिसमें हमने 5 mm का सरिया, जो कि नोकीला नहीं है, जो पॉइंटेड सरिया नहीं है, ब्लंट सरिया है, उसको हमने हथौड़े से ठोका है और उसके ऊपर कोई क्रैक पूरी सरफेस के ऊपर नहीं आया है। और उसी सरिये के ऊपर मैंने एक आदमी को लटका दिया है, जो 72 kg का है, चाइनीज, उसको मैंने उस सरिये पर लटकाया है जस्ट टू प्रूव। यहाँ कहते हैं एयर कंडीशन लगेगा, गिर तो नहीं जाएगा। मैंने आदमी को लटकाया है इसीलिए कि आप देख लीजिए, अगर आदमी नहीं गिरा है तो एयर कंडीशन नहीं गिरेगा।
Yes, that's a good, yeah, very good. Another question, I think that we have shown, but let me, whether RESs or surface conduit for plumbing and electric services, we have used RESs here, but can we use surface conduits? Ratan Singh ji?
Sure, sir, without any problem.
So
Without any problem.
both are applicable here, but here we are using RESs, okay? So we are doing chiseling and then we are putting the service conduit, but you can use surface conduit as well.
And sir, the conduits can be put in both ways.
Yes.
If you have a fixed place already marked on the drawing, you can insert the conduit in the main body of the panel also. If you don't want chiseling, if you don't want anything, you can see the video on the website. We have put complete in a villa, which we have made 2000 villa in Australia. We have totally all conduits have been put inside the body of the panel rather than chiseling and covering it up.
Okay, thank you, Ratan Singh ji. Be there. Next question is for me. Yes, RP Singh ji. Yes, we have done the pre-delta analysis. Also, let me share with all of you, because since we are using the new technology and for the first time, so all these designs which are being done by the agency, technology provider and agency, they are being vetted by IITs and other academic institutions, and we have gone a step ahead.
Sir, I have a question. I'm RP Singh.
हाँ, या प्लीज अभी एक मिनट इस क्वेश्चन का आंसर कर दूं, एक मिनट इस क्वेश्चन का आंसर कर दूं, फिर पूछिएगा. So what we have done is, we have gone a step ahead, because what we did, we created a group comprising of professors from IITs, including me, and the already vetted design by IITs were seen by all of us, and then they were cleared for construction purposes. So absolutely no problem. All static, dynamic analysis, linear, non-linear, p-delta, and all those things were conducted for all the projects, not only Indore but others as well. Okay. So now RP Singh ji, आप पूछ सकते हैं. You can ask.
Yes, sir. Sir, what I am saying is that in IS 13920, para I'm exactly not remembering clause. I can tell by seeing that is a concept of strong column, weak beam. This is a mandatory requirement for zone 3 and above. So how this is being made? Because here the column beam are made of structural members of steel structures.
RP Singh ji, आपने खुद ही उसमें इतना अच्छा लिखा था, आप ऐसा क्वेश्चन पूछ रहे हैं. That is for RCC structures. Okay. For steel structures, we have IS 800. So IS 800, how to design a ductile joint and beam and column is given. And as
sir, that is okay. My question is, this is a question I have written.
See, please, let me answer. I got your question, Singh ji. That is applicable. Strong column, strong column, weak beams.
That is universal, sir. I'm not saying that is applicable to this.
So you discuss with me later, because that is for RCC. Okay, that is not for steel structure.
It is okay for RCC.
मैं आपको बाद में समझा दूंगा. Let us.
जी sir.
Okay, see, this is ductile steel. Let me tell you, steel, inherent nature of steel is ductility. Okay. So the strongest comes from the joints. Okay. So we are designing the joints for shear, flexure, and axial. So shear, flexure joints, and then shear joints. So from there, all those pins you know, when you do a RCC beam column, so you have to have a pin thing. So here also in a similar fashion, joints are being designed. Okay, and inherently steel is a ductile material. So that thing is not applicable here. 13920.
No, sir. My question was totally. What I am saying, there is a formula. There is a formula that the capacity, irrespective of material, that is a 1.4 times the sum of the moment capacity of the column.
अब आपको बाद में बताएंगे, आप नहीं समझ
नहीं, ठीक है,
ठीक है. No, next question. Okay. Next question is Manish. Somebody is asking, can I get a certificate for this opportunity?
We do have a e-learning course on the website, which is available for all, including Technograhis, excluding Technograhis. So somebody can go and enroll themselves, and then they can learn and understand the concept, pass the modules, and the e-certificate will be generated. So the website is available to everybody. I've written the website details, so anyone can go and have an enrollment.
Okay. Another question, temperature notes. Yes, the temperature notes have been taken. Next question is, can I get the presentation? Yes, you will get the presentation on this mail. Ratan Singh ji, this question can you answer? Is there any chances of cracks at junction of panel and steel column?
No, sir, it is not. It is not, because the reason is that not only it is welded directly to the column, which Kashinath has already explained to you, we are putting the grout also still. We are not replacing the steel structure joint with the wire, but also same time putting the grouting material. So there is no question of any crack.
Okay.
I will just add to that small point regarding the cracks on the border. Like I mentioned, that cracks at the jointing between the pillar and the panel usually happens when people are using the C channel, U channel. Since we are not using any channels and we are installing it directly into the beam, that's why the cracks never happen.
Okay. Ratan Singh ji, another question for you. Will this structure be comfortable for users?
Sir?
Will this structure be comfortable for users?
Comfortable मतलब क्या, सोना चाहते हैं, कूदना चाहते हैं, खेलना चाहते हैं, क्या चाहते हैं?
Comfortable means thermal comfort, of course.
Thermal comfortation, sir. जब हम 550 डिग्री टेम्परेचर एक तरफ है और दूसरी तरफ 78 डिग्री है, तो इससे ज्यादा कंफर्ट क्या हो सकता है, सर?
Okay.
55. The panels have a fire rating of 3.5 hours. We have also seen that besides fire, there's water, termite, and also sound resistance of almost 48 decibels. We actually, my dad and I, we went to somebody's house where we did the sample house for NBCC. हम लोग पहुंच गए वहाँ पे. We rang the bell. We said, excuse me, some senior police officer was there. Sir, आप लोग क्यों आए यहाँ पे? Like we built this house. We just wanted to ask you. आपको यहाँ पे, you have stayed in this place, you have stayed in other government sites, which do you think is better? They said, in this place, we have always felt it is quieter and the weather extremation is not there. हमारा बिजली का बिल कम आया because we're using less heating and less AC.
Okay. So the next question is about, as the structure is mostly made of MS steel deck sheet, what about the climatic reaction? What about issues that will come after erosion? This project being affordable, will it be easy to maintain, or is it maintenance free? So Isha, let me tell you that now, with the advancement in the manufacturing of steel, now steel, steel is being promoted by the government of India in the residential sector. Number one. Secondly, steel being recyclable material, it is good. It is falling under sustainable material. Thirdly, these deck sheets are galvanized. Okay, so they are corrosion proof. Also, for steel beam and columns, we do a coating, anti-corrosive coating. So there is no question of corrosion. Also, in fact, if you saw my slide, we told you that all these new technologies, they have low life cycle cost. That means the maintenance cost is less as compared to conventional cost. Okay, conventional maintenance cost. Thermal
सबसे बड़ा डॉक्टर साहब, सबसे बड़ा एडवांटेज ये है कि जो प्लस्तर बार बार उतर जाते हैं 3 साल बाद 4 साल बाद, इसमें तो प्लस्तर उतरने का कोई सवाल ही नहीं. So question of maintenance is much better than the normal conditioner's house. There is hardly any maintenance. आप मर्जी से पेंट करा लीजिए 4-5 साल बाद जब भी बदलना हो. Otherwise, as far as walls are concerned, I can guarantee you there is no maintenance.
Okay. Okay, and I think we have answered most of the question. RP Singh ji, you can write down my number. I will explain you tomorrow in detail, because let us not bore all the participants, because you are asking purely structural engineering question. So tomorrow I will explain you that thing. RP Singh ji, you can write my number 987-111-4692. I will explain you tomorrow. Okay. Whenever you have time, you just call me. I will explain you that strong column beam, weak beam design philosophy, and how we design steel building for earthquake resistance. Okay. So if there are no more questions, we can ask Manish. I can ask Vikas. You know, I just missed this point. The entire effort of this webinar is a joint collaborative effort of Ministry of Housing and Urban Affairs, Climate Smart Building group of GIZ and BMTPC. So we have with us their head Vikas. So Vikas, would you like to propose vote of thanks, or before that, if you want to say something, you are more than welcome.
हम होस्ट में हैं कि गेस्ट में हैं?
आप गेस्ट में हैं सर.
तो फिर मैं आपको धन्यवाद कर देता हूँ.
नहीं, वो करेंगे ये. विकास जी,
Thank you very much, sir. Thank you very much. आप लोगों ने यहाँ पे बहुत अच्छा काम किया, sir. And you all people have done a wonderful job. That we are going to have 6 LHPs in place, and with the new technologies and innovative technologies. As you know, these technologies are being used at different locations in the world, and they are very much compatible. They are very much aligned with the economic scale what we have in India right now. So all these things will come to the conclusions that every aspects of engineering, civil engineering, has been covered over here, and we are going ahead with the new and innovative technologies with respect to construction. So we are creating a construction industry in that respect for the new technologies. As part of thermal comfort and energy efficiency is concerned, it is very much desired at this level, because we have the commitment internationally to do something with respect to climate issues as well. And it is well covered. What we are seeing, what we are analyzing here in all the LHPs, it is well covered, and it was well designed with respect to thermal comfort and energy efficiency both. And you see, when you're talking about Celeste, about the environmental aspect, everything, all the aspects like the walling material, the roofing materials, and of course the flooring. That includes the passive design of the building, including orientations, shadings. All things are covered. So you will find these technologies aligned with the environmental concerns as well. And certainly in the future, you will see many more LHPs to come in different states. So I would like to thank over here the participants who are very generous in their approach, and they have asked so many questions regarding all these technologies and thermal comfort as well, and environment concerns. So it is very natural thing that now participants and stakeholders are very clear in their mind what they wanted to have in these new technologies of constructions. So I thank you very much, Salesh sir, and I thank Ministry of Housing as well, Mr. Kuldeep Narayanji, who has taken this initiative to organize this series of webinars. In fact, the live thing, it is the first time that is happening in a webinar, that we are showing the cameras through live implementations of these LHPs. So it is a very much a good opportunity for the student as well, who come forward for a better educational landscape with respect to live laboratories of these LHPs. In fact, they can also organize summer schools. They can also organize studios over there at the LHPs, and we will definitely be supporting into it. So I thank very much to Mr. Gautam, who's the director of MHUA, and Manish ji as well, and whole his team of MHUA, who has taken a great pain and great time finish this type of webinars in series. And we are having many more series to come, many more webinars to come, and we are sure that you will all gain very good experience and very good learning systems through these webinars. Thank you very much, sir. Manishi.
Sir, before you leave, I think we have one more question which is actually different and important to answer. Shall sir? Is it possible to scale down the technology for independent houses? If yes, what would be the maximum distance of logistics to keep project affordable?
Okay.
You can just answer and then we'll leave.
Okay. I think this is a very good question. If I, because Ratan Singh ji is there, he's trying to make this technology affordable. Right now, he at one or two places. Once more, first of all, please understand all these technologies which we are talking about are based on a factory setup. And it depends on demand, supply, and economies. Right now, it depends on economies of scale. Economies of scale means if you have a minimum number of houses, a minimum built-up area, then only that technology becomes economical. But some of these technologies, like precast sandwich panel systems and all, they can be easily used for affordable housing as well. There is right now, if there are more plants, then technology becomes affordable. Like AAC panel and all, there are a number of plants, so they have become affordable. In fact, Ratan Singh ji is trying very hard to put up factories in different parts of the country. Only thing, it depends on demand. So once we have more demand, the technology becomes affordable. Just to give you an example of aluminium formwork, when aluminium formwork came to India 10 years back, it was very expensive, and now it can be used even for 10 houses. So same thing with these technologies. If there is demand, this technology will become affordable. But these sandwich panel systems, particularly these systems which are being used here, they can be easily used for isolated houses as well at the affordable cost.
Sorry.
Okay. And another thing I want to tell you, my nodal officer is telling me, if you want to construct a single story of this technology, is very, very good, because here it's a high-rise structure, so we are using it with steel. If you want to make an isolated house, it can be done with this panel, the precast and prefabricated sandwich panel system. And
yes, that exactly was my point, that if it's only G+1, then you do not need any kind of structure.
Okay.
Only the panels can be assembled together like Lego blocks, and the house can be made.
So that is pretty economical. Okay. So with this, I think Manish, can I ask?
Before we leave, I have two announcements to make. One, we have webinar series 3, which is coming on 30th of this month, same time most probably, from LHP Lucknow. So kindly note everybody if anyone is interested. And number 2, all the presentation and everything is available for today's webinar on the website. The website address is there on the chat box. So if you are interested in downloading and getting more information, you can access our website. Thank you, sir.
Okay. If all of you can, switch on your camera, we can take a photograph.
Yeah, please.
काशीनाथ भी जरा शेयर बंद कर दो अपना. काशीनाथ अपना शेयर बंद कर दो webcasting का, so that I can.
The share thing we'll close from our end.
Then we'll take a photograph.
Please.
Please make it a habit that once before leaving we should take a photograph. Okay.
Can everybody switch on their video and mute their mic?
Everyone can switch on.
We have almost today we touched 470 participants. Right now we have 266. So we should have all the pictures, all the faces.
Yeah, very good. Compliments to you, Manish, for time 400.
plus 500, almost 500.
Thank you. One more round.
Thank you.
Thank you very much. Thank you, everybody.
Thank you.
Thank you, sir. Thank you.
लेट हो गया जब तक
इससे आउट हो जाओ. सर्वर जो मेन है उससे म्यूट नहीं हो.